All right. So this is what's affectionately known as the horsepower lab, and it's a way to really compare the horsepower in our arms, which we figure out by using this apparatus, and the horsepower in our legs, which you may recall we run up and down the stairs to do stuff. Power in general is work divided by time. Work is force times displacement, the letter S for displacement in this course. We figured out that it takes 78 newtons of force to stretch this elastic band 0.25 meters, which is the distance between these photo gauge timers. So we have a known distance and a known force that's required to stretch out an elastic band. And so the product of force and displacement gives us the work or the energy that's being developed. As a rate of change, we divide by time, and then we get the power, the rate of change of work. And so the photo gauge timer sort of tells us the time. You can see my sample data here, where I was able to traverse the 0.25 meters in 0.0809 seconds, which yielded a value of 241 watts. And if you want to convert it into horsepower, there's 746 watts and 1 horsepower. So the answer to this question is 7.46 100-watt light bulbs in a single horse in terms of the power anyway. So this yielded a value of about 0.32 horsepower. For my legs, I have a mass of 100 kilograms. On Earth, that means I weigh 981 newtons, the SI units of force. And we traveled 24 steps, and each step was about 18.5 centimeters. And so the total displacement was 4.44 meters. Weight times height gives energy, right? MGH, the potential energy is also the work that I did lifting my weight equal to the potential energy that I possessed sort of at the top there. And the time that it took me to traverse that 4.44 meters was 4.5 seconds. And so by multiplying newtons and meters, we get joules of energy divided by seconds of time, and we get watts of power. My leg horsepower was 968 watts compared to my 241 watts of arm horsepower, 241 watts of power rather. And so converting this into horsepower, my legs had about 1.3 horsepower. That's about 4 times as much power as my arm. And so that's the data that needs to be collected in order to determine power for both the arms and legs.